Hello everyone, welcome back to 3 Deviations. In today's video of single variable calculus, we are going to be finishing off our study of Unit 5 with our final topic of the average value of a function. Now, this is a major tool that we're going to be able to use to determine the weighted average value of a curvy function like that. So we can determine where the midline is with a weighted sum. In this video, I'd like to derive that notion, and then we will also do an example, which will test our values and test our familiarness with the substitution rule, which is going to be very important in the next unit. So we will get started with that right now. So first, let's define what I mean by the average value of a function. So if I want to find the average value of some line, then I'm going to take all of the y values that I have over a given distance, and then I'm going to divide it by the little amount of subunits I've divided that distance into. Now in function notation, we can rewrite this as f of x sub 1 plus dot 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 all the way up to f of x sub n over b minus a over delta x. This can be neatly rewritten into a sigma notation where we have 1 over b minus a times the sum from I equals 1 to n of f of x sub I times delta x. Now, of course, whenever we see something that looks like this, the words Riemann sum should immediately go into your head, and also that our sigma is somehow going to turn into an integral. And that is exactly what happens. We get that our average value of the function is equal to 1 over b minus a times the integral between a and b of f of x dx. Now that we have that under our belt, why don't we do an example? So, I would like us to find the average value of sine of x squared times 2x over cosine of x squared between 0 and 1. Okay, so what we need to find first is we need to determine 1 over b minus a. Well, we already know that a is equal to 0 and b is equal to 1. Well, if I subtract 0 from 1, well, then I'm just going to get 1 over 1. So that's immediately important. Now we're going to deal with this mess of a function. So this gives us 1 over 1 times the integral between 0 and 1 of sine of x squared times 2x over cosine of x squared dx. Now, what we are going to need to do is we're going to need to do a u substitution. We're actually going to need to do more than one u substitution, but we are going to get that u equals x squared. For a successful change of variables, we're going to try to modify the argument of this sine function. So we're going to get u equals x squared, then we take the derivative of x squared, we get 2x. We tack on the dx, then we get du equals 2x dx. Now we also need to change our bounds. We need to square our original bounds, so 1 squared equals 1 and 0 squared equals 0. So our bounds actually stay the same. So this gives us the integral between 0 and 1 of sine of u over cosine of u du. Now many of you who are, well, probably not so savvy with trigonometry, but know just enough, will know that this equals the tangent of u. But because we are calculus students, we are going to push forward with another example of the substitution rule to evaluate this function, because this is going to be important again in the next unit. So this gives us that we are going to need to set v equal to cosine of u and dv equal to negative sine of u, and that should be a du. So now we have another successful change of variables, but we need to change our bounds again. So v is going to be equal to the cosine of 1, and v is going to be equal to the cosine of 0. Now, we are going to deal with this later, but we are going to keep answers exact for this problem. So this gives us the integral between cosine of 1, or cosine of 0 and cosine of 1 of negative dv over v. And everybody should know that this goes to the natural logarithm function of whatever v we are dealing with. So we actually don't need to do reverse substitution anymore, because we have changed our bounds as well. So this gives us this being equal to negative natural log of v evaluated between cosine of 0 and cosine of 1, and that is equal to, using our logarithm properties, negative natural log of cosine of 0 over cosine of 1. Actually, that should be the reverse. So we have cosine of 1 over cosine of 0. Cosine of 1 over cos of 0. Alright, thank you for watching this video of 3 deviations. We will be back in the next one to discuss some more practical examples of the average value of a function. We will see you in the next one. Have a great day.